Hello and welcome to day 6 of our 42-day STL Mastery course. Today is where we shift gears a little. We are moving from theory to full-on practice. Vectors are one of the most versatile and commonly used STL containers. And today we will not only solidify your understanding of them but also apply our knowledge in real-world scenarios, from basic manipulations to more thoughtful problem solving. This is our vector test drive today. Let's dive in. Let's begin with our objectives for today. First, we will reinforce our foundational understanding of vectors, making sure you are comfortable with how they are declared, modified, and accessed. Second, we will move into active problem solving, where you will implement what you have learned in code. Third, we will highlight common mistakes and pitfalls so we know what to avoid in interviews and real world applications. And finally, the goal is to boost our confidence when using vectors so that they become second nature in our STL toolkit. Before we dive into problems, let's refresh a few critical concepts. We should already be comfortable with how to declare and initialize a vector, either with default values, specific size, or initializer list. Access methods like the subscript operator, the add method for bounds checking, and accessors like front and back are essential. You also need to know modifiers like pushback to insert at the end, popback to remove the last element, and insert erase and clear for more control. Don't forget the difference between size, the number of actual elements, and capacity, which refers to the amount of memory currently allocated. Understanding these will help you not only write functional code but efficient code too. We will start with some warm-up problems to activate our STL neurons. These are relatively simple tasks but incredibly useful to build fluency. Try writing a function to sum all the elements in a vector. It's straightforward but a great place to start testing loops and iterators. Next, reverse a vector using both a manual loop and STL's reverse algorithm. Compare them. Try inserting an element at a specific position. Remember that indexing matters. Implement duplicate removal in sorted vectors. Use STL tricks like init combined with erase. And finally, the max and min values in a vector, both manually and with STL functions. These tasks may be simple, but they are core building blocks for everything ahead. Are you ready to level up? Let's move to intermediate challenges. First, try rotating a vector to the left by k places. Do it manually without building rotation functions at first. Then merge two sorted vectors into one sorted, of course. Don't forget to handle edge cases like unequal sizes or empty inputs. Next, compute a running sum where each element becomes the sum of itself and all previous elements. This is a great test of accumulation and loop control. The second largest element problem is a common interview favorite. Can you find it in one pass? Finally, try creating a frequency counter, either using a vector or combined with a map. This is an intro to combining STL containers for real utility. Vectors are simple until they are not. Let's address a few common mistakes that trip up even experienced developers. First, be careful with index out of bound errors. The subscript operator does not throw exception. At does. A lot of people confuse size and capacity. Size is how many elements are actually there. Capacity is how much memory has been reserved. If you are using vectors, don't forget to clear or resize them, or you might be building on top of slate data. And a big one, iterator invalidation. If you use insert or erase, it may invalidate iterators you are using in loops. This leads to subtle and painful bugs. Be mindful of this. Avoiding them will make your STL usage clean and professional. Now it's time to switch gears and get hands-on. You will be solving a series of problems. We recommend picking at least 4 to 6 from platforms like LeetCode, HackerRank, or Gigs for Gigs. You can also use the Code Sandbox or your local IDE. Focus on writing clean code, testing with edge cases, and following the problem constraints. This is where you apply everything from the past 5 days and build real confidence. If you hit errors, don't worry. Bugs are your teachers today. For those who finish early or want a challenge, here's your stretch problem. Implement a sliding window maximum algorithm. You will be given a vector and a window size k, and your task is to find the maximum element in every sliding window of size k. Now the catch is, do this without using the DQ container or other advanced tools. Brute force it using just vectors. It may not be optimal, but it will push your logic and STL command. Try to make it efficient, and we will look at how to optimize it in upcoming sessions. Once you have worked through the lab and stretch problem, we will now we will come together as a group to debrief. We will review the most interesting and tricky questions, discuss how people approach them, and analyze different solutions. This is a great time to learn from your peers. Often, someone's shortcut or insight will help you improve your own coding process. Feel free to ask questions or share alternate solutions. This is a safe place for growth. Before we wrap up, here's your homework. Solve at least 2 intermediate level problems related to vectors. Pick something that challenges you. Explore the difference between using vector int and using and vector int. Understand memory layout, access patterns, and use cases. And optionally try implementing a matrix transpose using a 2D vector. It's a fantastic way to deepen your knowledge of nested vectors and grid manipulation. And that brings us to the end of day 6. You have done some solid work today, reinforcing core concepts and applying them through hands-on problem solving. You have, if you have any questions or if there were problems you struggled with, now's the time to ask. Don't hesitate to revisit today's lab later or discuss solutions with peers. Thank you for your focus and participation, and great job taking your STL skills to next level.